So we're going to introduce a new concept for counting, and we're going to do it with an example. So my example is how many three-member committees are possible in the class if there are 26 students. And by committee, I mean that the three are going to work together, but there are no distinction between the roles they're going to play in the committee. All three are going to participate in the same way. So here the order is not important. So what I said that the duties, what they're going to do in the committee, they're going to work together in the same way. As we say, the term we're going to be using is the order in which we selected them is not going to be important. This is different than in the permutation, where in my example, the first student would work in the commute project, the second in the textbook project, and so on. Here, the order in which they come out is irrelevant. The committees formed by the students John, Maya, Peter is the same as the committee formed by John, Peter, Maya. Yeah, so if I selected one, if I put the names in a bowl and they came in the first order or the second order, it's irrelevant. They are the same committee. Okay, so that's what I mean by the order doesn't matter here. So we need to know if I count all of them, like all the committees like before, if I know how to find the ones where the order mattered, that was 26 P3. There are 26 students in this one behind my face, yes. But now if I count that way, I'm counting multiple times each committee. Yeah. So I had that number. Let me do it again. I can do 26 P3, which was just 26 times 25 times 24, so 15,600. So this number is 15,600, but I'm counting multiple times. So if I had, this is not going to make any sense, but if each of these dots represents one possible committee, right? Pretend I have the 15,000 dots right there. Okay, if each of those dots represents one committee, then I'm counting multiple times the same committee, right? Like the example up there. How many times am I counting each committee? Well, let's think with my example. I have John, Maya, and Peter. I could have it like John, Peter, Maya. Those are the two that could have John at the beginning. If I put Maya first, it could be Peter and John. Sorry, or it could be John and Peter. And what's missing, if I put Peter in first, then it's Maya and John, or John and Maya. And those are all. I did it in a systematic way, so the first couple both have the J in the beginning, then they have the M in the beginning and the P at the beginning, so then you just swap the other ones, right? So I know I counted them all. This was not the best way to count them. We know how to count this. This is just, if I want to put three letters in three spots, right, we know how to do that. It should be 3 for the first spot, 2 for the second, and 1 for the last one. So it's 3 factorial. So it's 6, right? So yeah, we know the answer for this. It's of course it's 6 factorial. It's 6, sorry. It's 3 factorial, which is 6. So what I need to do, now I know how many times I'm counting them multiple times, is count how many groups of 6 do I have, right? I will count, like if each one of my circles represent that I'm grouping the 6 that represent the same committee, right? Every time I'm counting them. So what I'm doing is dividing the 15,600 divided by 6, right? And that 6 is the 3 factorial. So this is going to be our answer. It's 26p3 divided by 3 factorial. I'm going to go to the calculator to find a number. And by the way, when I press the stat, maybe you did see that here's the NPR. So if I press NPR in the calculator, it gives me this parentheses to put the two values of N and an R. So if I put 26, comma, the 3, right, it gives me the same answer that I have above. So this is going to be useful later when we use big numbers. Like if I want to do 26p15, right, writing it the top way would be a pain, but writing it this way would be very simple. So then this divided by 6. So I can use that divided by 6. So sorry, you maybe didn't see what I did. I just pressed, let me do it in the keyboard. So I just press the division button, okay, and then of course just put the 6 right there. So 2,600 committees only. So it reduces a lot, right? Okay, so this is 2,600. So this is called a combination. So a combination is going to be a collection in which the order is not important. That's the difference between a permutation and a combination of n distinct objects. In my examples, that was the people, without repetition. So again, you cannot repeat the same person, right? You cannot be John, 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 the committee. So it's written NCR, and the formula is the one we just showed you. This is the NPR divided by R factorial, right? Remember the NPR is n factorial divided by n minus R factorial. So these two terms are the NPR. So that when you divide this by n factorial, like we did, it just becomes like doing this. Yeah, so that's, sorry, not n factorial, R factorial. But divided by R factorial, it looks like I have in the formula. Okay? So that would be this R factorial, that's right there. And the calculator, again, if you paid attention, or I did it very quickly, when I click the stats menu, the NPR is right here, but the NCR is next to it. So if I go to a new line here, I can go to stats, press the NCR, and then just do the 26 with the 3, and I get directly the 2,600. Okay, so you don't have to do 2 steps. You could just do the NCR and the calculator to get these numbers. Okay, to do a quick example. Sorry, I was writing this down. Let's do a quick example. To win the lotto in a certain state, assume that you must correctly select 6 numbers between 1 and 50. The order in which the selection is made, it does not matter, right? That's important for lotteries. For the lottery, they have these little ping pong balls in the big sphere. They're below air, and eventually one pops out. That's your first number. Then another number comes out, and that's the second number. So the order in which they come out doesn't matter. You have your selection of 6 numbers, and if they match, it doesn't matter in which order they came out. You're going to have the order probably from smallest to biggest in your ticket. The way they come out is not going to be in that order. But if you have the same set of numbers, you won the lottery. So what's the probability that you win that lottery if you get one combination of 6 numbers? So we need to know how many selections are possible, right? And we're selecting 6 numbers from 50 numbers. So that's exactly, the order doesn't matter. The numbers cannot be repeated. So this is an NCR. Yeah, so it's going to be 50C6. And I just did it. 50C6 is 15,890,000. So you only have one combination, one of those. So it's 1 divided by that is a probability, right? And it's 6.2 times 10 to the negative 8. So it's very small. I'm not saying that it's impossible to win lottery. It's very small. If you know that your chances are very small, it might be fun to play the lottery. But you have to know that this is probably how you will win. Some people has to win eventually, and some people get lucky. Okay, I'll stop this one right there.